Earth's climate is changing rapidly. The world is heating up. These are undeniable facts, and the culprit for this very recent, very rapid change is us. With the help of fossil fuels, humans emit billions of tons of carbon dioxide into the atmosphere every year. But when you think of carbon emissions, you probably imagine the cars on the road, the power running from your apartment, or even the electricity in the light bulbs above your head. If we look at the breakdown of the 51 billion metric tons of greenhouse gases we emit every year, however, electricity only accounts for 27% of the problem. It's not even the biggest sector in terms of emissions. That award goes to the oft-forgotten manufacturing sector. Emissions from manufacturing come from a wide range of building materials like plastics, steel, glass, and aluminum. But today, we're going to zoom in on one of the most polluting materials in the manufacturing world, which is also one of the least mentioned materials in terms of emissions: cement. We build a lot of stuff. And a lot of that stuff, from the Three Gorges Dam to the Sydney Opera House, is built with concrete, which is a mixture of sand or gravel and a cement paste. Globally, we produce 4.1 billion tons of cement every single year. The US alone creates roughly 96 million metric tons, and China develops over half of the world's cement at 2.2 billion tons per year. We use so much of it because, to be quite honest, it's the perfect building material. Concrete is extremely durable, versatile, inflammable, and weatherproof. But concrete also has a large downside. In order to create cement and ultimately concrete, you also have to emit a lot of carbon dioxide. In fact, for every ton of cement made, a ton of carbon dioxide is released into the air. This happens because of a particular chemical reaction that occurs when raw materials are turned into finished cement. After raw limestone and clay have been ground up and mixed with other materials like ash, they are fed through a massive cylindrical kiln that gets heated up to 1,450 degrees Celsius. Within these large kilns, a process called calcination occurs, wherein raw materials are split into calcium oxide and carbon dioxide, and the final product becomes solid gray balls known as clinker. The byproduct of conventional cement, then, is carbon dioxide. CO2 emissions from the chemical process account for 50% of cement's total footprint. Another 40% of cement's emissions come from the burning of fossil fuels to heat the kiln up to extreme temperatures, and the final 10% comes from mining and transporting raw materials. In short, 90% of the CO2 emissions from cement come from what happens in and around that big cylindrical kiln. As a result of these emissions, the cement industry generates 2.8 billion metric tons of CO2 every year. That's 8% of the total global CO2 emissions. This means that if left unchecked, the growing cement industry could prove a huge obstacle to getting to zero emissions by 2050. It also means that cement offers a chance to drastically reduce global emissions quickly if done right. When it comes to greening the cement industry, there are a lot of proposed solutions. From geopolymers that harden at room temperature to using bacteria to grow concrete blocks, innovators are all scrambling to find the next alternative cement. One of them, a 2013 startup called Solidia, represents an exciting development in the world of cement. The company has developed an alternative chemical process for cement which reduces both energy use and emissions by 30% during the manufacturing phase. But the most promising part about Solidia's cement is that they use carbon dioxide instead of water in order to harden their concrete blocks. This means that not only does Solidia cement conserve fresh water, which for an industry that accounts for 9% of total global industrial water use is huge, but it also means that Solidia's concrete blocks can sequester carbon. As a result of the decreased energy demands, reduction in emissions in the kiln process, and absorption of carbon during curing, Solidia claims they can reduce cement's carbon footprint by 70%. Meanwhile, in Silicon Valley, a startup called Blue Planet is approaching the cement problem from a different angle. They've developed a technology to create synthetic limestone aggregates, which are basically just rocks, by capturing carbon emissions from flue gas. This synthetic aggregate can then be used to replace the traditional materials like sand and gravel in the final concrete mix. Blue Planet claims this low-cost carbon sequestration method could theoretically offset all of the emissions from the cement creation process. In essence, the amount of carbon that Blue Planet's synthetic limestone captures could potentially equal the amount of carbon the cement production process creates. These solutions, however, aren't without barriers. Solidia's cement curing process can only happen at a factory, which means its applications are limited compared to conventional cement. Blue Planet's aggregate process only comes in after the cement has gone through the kiln, meaning that its carbon capture properties are really just trying to make up for the emissions created during the kiln process. On top of that, both these companies have yet to really hit the market and be proven at scale. These alternatives have a long way to go, in part because they're entering an industry where safety and durability are king. So in the eyes of builders and safety inspectors, the tried and true conventional cement almost always trumps new varieties and inventions, which means that without significant government backing and policy change, the concrete industry will stay rigid. But we should not just wait for new technologies to hopefully save us one day. The way we build and how much we build can also greatly influence how much cement we use. According to a research paper by Chatham House, designing cities based on a capillary web system could decrease car use by 2/3 and cement demand by 1/3. If employed in places like China and India, where construction is booming, this type of smart design could mean huge reductions in concrete and, ultimately, emissions. At the end of the day, developing new technologies is just one part of our global concrete problem. Only combined with government policy, smart design, and reducing consumption can we truly create the building blocks of a zero-carbon world.